All right, so today let's look into this amazing networking project on Cisco Packet Tracer. So this project, I named it Secure Multinational IT Company Design and Implementation. It comprises of several sites, one in New York, another in Florida, another one in California, and there is another site in Canada. Okay, so I'll just I'll go to our packet tracer here. Okay, and maybe explain more about this project. So this project actually is available in our website. So if you go to our website, Gurutech Networking, gurutechnetworks.com, then you just click under download projects. Then you go under this category, which is the advanced and secure networking projects. You just click that one. Then on the list, you're going to take the first project. All right, so the first project, if you click it, the name is Secure Multinational IT Company Network Design and Implementation. Right, so I just have a quick explanation of this project. So if you need this project, just go to our website and you can just download this project. So if you download this project, there's a zipped file, and the zipped file contains all these files. You get a complete Cisco Packet Tracer file. You get a complete documentation that explains everything step by step. Then there's an IP addressing table. There's a case study, which is actually available on this website. So this is the case study, okay? Then as well, you get a project screenshot, like what I got here, okay? All right, now let's explain more about this project. So on the screenshot, I'm just going to explain the physical part of this this project, and part of the maybe the logical part, physical and logical design parts of the project, okay? Then the implementation part, which involves code, I'll go back to the packages, okay? So if you see this project, first thing that comes into your mind is redundancy, okay? Let's start with the access layer. You can see that each access switch connects to at least 2 multi-layer switches, and each multi-layer switch connects to at least 2 core routers, okay? Then we have only one firewall, okay, to manage inside, outside, and the DMZ zones, okay, per site, okay? Then you can see we've implemented EtherChannel here. We have implemented EtherChannel between the multi-layer switches as well as HSRP, okay? That's a very important implementation there. Then, as you know, segmentation. Every site and every department in any site should have a VLAN number plus a network subnet network allocated, okay? That's something that is there. And in every site, we should have a wireless connection, such that wireless devices can be able to access our network, okay? In every site, we should have a printer, we should have a computers, etc., etc., okay? Okay, as you can see, it's pretty much simple here. It's a kind of a very simple design, okay? Then in every site, we should have both inside, outside, and the DMZ zones. We have a server farm here, okay, that provides server resources to these clients on this side, okay? So the server farm here is managed by the firewall. So this firewall here protects our server farm, and it as well protects our inside users here, okay, internal network, okay? Then the firewall here, we can see it connects to at least 2 ISPs for redundancies, okay? So the ISPs you can see connects to cloud. So let's say these are the guys in United States of America, okay? So there are, let's say, we have sites in New York, Florida, and California, both in America. Okay. Then we just dedicate two ISPs, one as primary and one as secondary for all the sites. Okay. Then we connect them to the sites. All right. Then importantly, these ISPs connect to a kind of global internet. Okay. Because we need to reach Canada. Okay. So it connects to global internet, where as well the Canada ISP connects. Okay, the Canada ISP provides internet connectivity to our Canada site via the firewall here. Okay, both sides, you can see all sites have their server farm available that provide server resources to the clients there. Okay, all right. So another thing that I want to explain here, in this project actually, I have used OSPF as the routing protocol on the routers and the multi-layer switches and as on the firewall. And as well, I've used static IP addressing on the firewalls because, you know, firewall will act as our security device as well as the edge device. Okay, it's the one connects to the ISP. So when it connects to the ISP, it needs to do some static routing there. Okay, all right. So another thing that I've configured here, I've mentioned HSRP and EtherChannel. So the HSRP that I've the EtherChannel that I've configured here is PAGP, which is Cisco proprietary. Okay. Then another thing that I've missed here, all the devices, apart from the server farm devices, all the end users devices will get the IP address via DHCP. And who is going to allocate the IP address to the devices? It's the site's DHCP server. Okay. And as well, you can see we have email server here, we have DNS server here. Okay. All right. So another thing that I can say here before we go to documentation or the packet tracer file. Okay, the traffic flow. All right, let's assume this guy here wants to communicate with even this guy in Canada. Okay, so how will the traffic goes? The guy will try to ping this guy. Okay, but the first traffic will go through the Ethernet or the wireless. Okay, it's wireless to the access point here. Okay, the access point actually is connected to the switch here. Okay, so the traffic upon reaching the switch, it will either go to this switch or this switch. But remember, we've configured what is called HSRP in these two switches. Okay, so the primary one, the traffic will go via the primary switch. Okay, so let's assume this is the primary switch, this is primary, and this is the standby. So when the traffic comes from this guy to the access layer switch here, it will go to the primary switch here. Okay, then using the routing protocol. Okay, now it's routing protocol. It will either go to these two routers. Okay, let's assume now it comes to this router. The router will forward traffic to this guy here. Okay, which is the firewall. Okay, so the firewall has been configured in a way that this is the primary ISP. So it will forward that traffic to the primary ISP. The primary ISP will forward the traffic to the global internet. Okay, okay, all right. So remember, these routers and firewalls or the intermediate devices checks the source and destination of the of the packet before forwarding that traffic. Okay, so the internet routers will forward the packet to the Canada ISP, which forwards to the firewall here. The firewall, based on the routing protocol here, will forward to either of the two switches, okay? Then the two switches will eventually forward that traffic, okay, to access layer switch in that particular department, and finally the traffic will reach this guy, okay? It's pretty much simple, the traffic flow, okay? All right, then another thing that I can say here, I don't see. Let me just go back to the documentation. Like I mentioned, this project comes with the documentation. So this is a zipped file. So if I click that documentation and let's go. So these are all that have been implemented in the project. So we go with the introduction, the proposed network design and implementation, the layered hierarchical network design. So that's very important. As you can see, these are 3-tier hierarchical network design. We have access layer, we have aggregation layer, we have the core layer. Okay. All right. Then another thing, redundancy and scalability. Just see, when this switch fails, okay, we're gonna use this one. If this router fails, we're gonna use this one. It's only that the firewall has been used as a single point of failure, but per this requirement, it's just gonna stay that, okay? We have 2 ISPs here, okay? All right. So another important thing here, network protocol and design strategies, okay? Then we go with we call it device choice and naming convention. So if you check on this packet tracer here, you will see that there are specific devices that we have chosen. Okay, if it's a switch, it's a 2960 access switch. Okay, if it's a multi-layer switch, it is a 3650 multi-layer switch. The routers we do with 2811 route. Okay, and the naming convention, we name the devices based on the site. If it's a New York printer, just include that acronym there, New York, etc. Okay. Then we go with design IP addressing and allocation. IP addressing table, very, very important in this. IP addressing table is very, very important. We have a very detailed IP addressing table for everything in this network. Okay. All right. So another thing that we have there, let's go to the table of content. We have VLAN configuration. Okay. No, basic device configuration. So the basic device configuration includes a lot of things. So let's just take one multi-layer switch here. Okay. And maybe let's go with access switch. Yeah. So I don't know the password. I just click here, go back to CLI and say do show start. Okay. So the basics device configuration, we have hostname. Okay. Then we have enable password. Okay. Then as you can see, the password has been encrypted, and which command has encrypted the password? It's this one. Okay. We have SSH here. Okay. We have disabled IP domain lookup. Okay. We have IP domain of the switch. Okay. Then we have the user and the password. Okay. The username and the password, which we'll use during SSH. Okay. Then interfaces. Interfaces has been configured as trunk, others as access interface. Okay. And as you can see, the interfaces that have been configured as access, they have been allocated VLAN numbers. All right. So another thing that is configured here is a banner MOTD. So the banner MOTD basically tells us or gives us a direction or warning before maybe we log into the switch. Okay. We have a line console 0 password. Okay, line VTY as well. All right, so that's about the basic configuration on the devices. Okay, so another thing that we need to do, I just want to inform you that whatever you've seen here applies to most of these devices, except the firewall. The firewall actually has unique configuration, so I'll show you that later. Okay, so we have VLAN configuration. So like I mentioned, each switch here has, you can see this is in VLAN 20, VLAN 30, okay? But the multi-layer switches must have record for all the VLANs on the access layer, okay? So to see that, we just go here and click anything there and say do show VLAN. Here we have all the VLANs in this site, okay? So this one you can check on every switch, okay? All right, another thing that we have here is inter-VLAN routing. As you know, by default, devices in different VLANs do not communicate. And how do we make them to communicate? We implement what's called inter-VLAN routing. And how do we do that? In this scenario, we implement what is called switch virtual interface inter-VLAN routing. Okay, there are two types. So there's a router on stick which is implemented on the router, and there is a switch virtual interfaces that we do it on the multi-layer switches. So how do we show the inter-VLAN routing configuration? Do show start. So we just see them on the there's a sub interfaces that are created. Yeah, they are there. So you can see there is a sub interface that has been created for VLAN 10. Okay, and we have a description here. The MAC address actually is assigned automatically. We need to give IP address of that sub interface for inter-VLAN routing. Okay. Then there's one thing that I would like to combine here. HSRP. I don't know whether it's here. Yeah. Yes, HSRP. Yeah. So you can see there's a standby there. Okay. The standby number with the IP address tells that HSRP had been configured here. Like I mentioned here that there are two switches here, and we need to do correct load balancing and ensure that whenever one fails, all the traffic goes to this one. And before that one, we need to dedicate one switch as our primary switch. Okay, so let's assume that this is a primary and this is a secondary. So we implement what's called auto standby router protocol. Okay, HSRP. So just say do shows standby brief. Yeah, so you can see this is our active router. You can see active is local, but the standby is the one with this IP address. Okay, we have a virtual IP there, which is necessary for HSRP configuration. Okay, so you can see it's applied to every sub interface with the VLAN ID. Okay, whatever we are seeing here. Yeah, here. Okay, all right. So another thing that we need to do here is EtherChannel. So the EtherChannel, actually, like I mentioned, it aggregates two or more logical channels into two or more physical channels into one logical channel. So in this regard, we have aggregated these two interfaces into one logical channel. So you can see here, I think here maybe there are some issues with the STP, but you can see here they have been aggregated into one logical channel. So if you can just go here and say do show EtherChannel. Do show EtherChannel. Yeah, you can see we've configured the protocol as PIGP. Then how many ports? 3 ports, but we can configure up to 8 ports. Okay, we have how many channel? Logical channel is only 1. Okay, so you see all these 3 interfaces have been aggregated into one logical channel. So the data is transferred through them as one logical channel. Okay, all right. So another important thing is server farm static IP addressing. So as you know, the server farm, actually the server should always have static IP addressing. So that's not a big deal. It's something that you allocate here, okay? Based on the addressing table that you have. Okay. Another thing is DHCP server configuration and host allocation. So like I said, each site has a DHCP server that dynamically allocates these devices IP addresses, okay? So for example, in this server, we have configured a DHCP pools for each site, okay? So let's go here and let's see. For example, in New York, we had set A, set B, set C, and set D. So we go to services, then you click on DHCP, and you see the sites here. So for example, site A pool, you can see we need this is the default gateway. The DNS server will always remain the same in all the users, okay, all the devices, okay. So start IP address, yeah, you can see, yeah. So I think that's all about, and you can see we have the 4 pools there, okay. All right. So another thing that we need to configure here is OSPF. So OSPF is a very important thing, and it's the routing protocol that enables the packet to come from here through all these devices to the destination. And we implement it on the layer 3 devices. So we start with the layer 3 switch here, okay, which has capability of doing routing. Do show OSPF neighbors. Okay. Let me check it here. I don't know what I'm doing wrong. Oh, it's not neighbors, it's neighbor. Okay. Typo. It should be IP. Sorry, it should be IP. I'm getting old. Okay. All right. So do show IP OSPF neighbor. So you can see this router here has how many neighbors here? Close to 6 neighbors. And how many? Where are those neighbors? 1, 2. And this switch here has how many VLANs? 4 VLANs, and each VLAN is in a different network, and we have configured sub interfaces in this switch. So each sub interface will form an OSPF neighbor with a similar sub interface on this side, okay. Right, so that's why we have 6 OSPF neighbors here. All right, okay, so you can see the interfaces are gig 101 and gig 109. Then the others are the VLAN interfaces. All right, so another thing that we need to do there, let me see. Another thing that we need to do is the default static route configuration. The default static route configuration, like I mentioned, is done on the firewall, because the firewall communicates with the ISPs. So we need to implement default static route there. Show enable. Oops, I forgot the password. Cisco. Yeah. Show start. So let's see the default static routes. Why can't I see it? Where was it implemented? Let me see. Default static route. On the perimeter firewall, but I don't see that. Maybe I forgot that. Let me see which perimeter firewall is that. Let me check again this one. I can't see it here. Okay, so I think maybe I missed that, but even if I missed it, I did configure OSPF in all the firewalls, so OSPF will still work, but it should be here for real world networks. Okay, it's not here. Maybe I missed that part. Let me see which firewall is this. Perimeter firewall 1. Okay, is there any firewall with that name? Yeah, I think. Okay, no problem. So I'll skip that. But it's there. It should be there. If it's not there, then OSPF will cover for it. All right. Then we have site-to-site IPsec VPN configuration. Okay. Then we have, let me see where this was implemented. Okay. All right. So this was implemented on the site VPN were implemented on the routers, which is not a good practice. Okay. So this was 2023. Okay. So I'll not discuss the site-to-site VPN. I'll go with the Cisco ASA firewall. The site-to-site VPN should have been implemented on the firewalls. Okay, this firewall, this firewall, this firewall, and this firewall, and not the backend router. It should be on the firewall. Okay, so I think I have a project that have implemented site-to-site VPN on the firewall. All right. So another thing that we need to discuss here is let me see, Cisco ASA firewall. All right. So if you go into every firewall, then you just say show start. Okay. We have a host name. Okay. There we have enable password. Okay, which is encrypted. Then, like in the firewall I mentioned, we have what's called zones: inside zone, DMZ, and outside zone. So you can see, for example, in this firewall, we should have 2 insides for this interface and for this inside. For this interface, okay? Then 1 DMZ interface, this one. Then 2 outside interfaces, okay? Those are there. 2 inside, 2 outside, and 1 DMZ, okay? And you can see each interface has a security level and IP address. So for example, for inside zone, the security level is always 100 because it's trusted 100%. Okay, but something that goes outside, security level 0. Okay, we partially trust our server farm. We give it like 70 or 50. Okay. Okay, so we have NAT configuration here on the firewall. Then, as you know, this is not a physical device. This is just a packet tracer. To allow communication, we need to write some access control list, okay, that permits packets based on the service. For example, www is, I think it's HTTP. Then this is the DNS. Boot PC and boot PS, I think it's DHCP. Okay, yeah, I think that's all. And then you effect this access control list per interface. Okay, so whenever traffic goes through an interface, this these rules must be applied. Okay, all right. Okay, so another thing that is implemented here, OSPF is here on the router, or on the firewall. Okay, all right. So let's see another thing, wireless configuration. Okay, so we have a wireless configuration here. Okay, you can take a look here. Another thing that is there, let me see. Communication in the network. So we need to test. So let's assume that this guy here wants to communicate with this guy here, okay? Someone in New York wants to communicate with someone in California, okay? So I'll just get IP address of the California computer and IP config. So we copy this IP address. Okay, then we come to this. Let's try it from this wireless device, and let's check the IP address, IP config. Okay, now ping that guy. So you can see the IP address here is 1.10, but this guy is 6.144. Okay, let's see. I think the first two might always fail due to ARP when the host is trying to discover the other guy. But let's see the subsequent one. Yeah, perfect. So if you test again, now we are going to achieve 100% connectivity. Yeah, so guys, thank you for watching. If you need this project, please go to our website and just download the project. You'll be taken to PayPal, where you make some donation. Then you will be redirected to our Google Drive to download the file. Thank you so much and enjoy the rest of the day. Bye bye.